Hello friends, today we have got another question and this is our given differential equation of higher order with variable coefficient, that is x square, and they are variable, so it is our Cauchy linear equation or Cauchy homogeneous linear equation. And if suppose there is ax plus minus b with the derivatives, then it will be our legendary equation. But here we have got only x, that is ax, only multiplied with derivative, then it is our Cauchy linear equation. So we know the way how to solve this equation discussed already. So let's move ahead. Whatever there is the variable coefficient multiplied with the derivative of y, we will substitute that coefficient with e to the power t. So here is x coefficient, so we're going to substitute x with e to the power t, so that and taking log on both sides we get log x is equal to t. If you don't know how to make this equation into symbolic form, then please go to the introduction video of Cauchy homogeneous linear equation, where you can get detail about how to convert the given differential equation into symbolic form. And wherever we get the first derivative and x with the first power, we're going to replace it with dy. And similarly, second derivative with the power square of x, we're going to replace it by d into d minus 1 into y. So with the help of this substitution, we're going to get our given equation into symbolic form. This is our equation and this is our right hand side. So finally we got our symbolic equation like this: d into d minus 1 into y plus dy plus y equal to right hand side. Look, we have substituted x with e to the power t, where we got log x is equal to t. So here is log x, so we will replace log x by t, then it become t sine, this is also log x, it become t, then t into sine t. So we got this symbolic form, and our right hand side, our given differential equation is also changed in the form of t. So we will take y common from this side, so finally we are going to get the coefficient of y, this all. And we know if we equate the coefficient of y equal to 0, we're going to get auxiliary equation like this. So its auxiliary equation is the coefficient of y equal to 0. Finally, on solving this side, we're going to get this much form, d square plus 1. And after this, we know how to calculate the d value. And the calculation, we get d equal to plus minus I. Plus minus I means 0 plus minus I, which is imaginary form, from where we can get our alpha and beta value. So after getting our alpha and beta value, we can get the CF for roots are imaginary. So CF equal to, we have got the formula, CF equal to e to the power alpha t. Look here, we are using t, means our formula is e to the power alpha t bracket c1 cos beta t plus c2 sin beta t. Look, whatever there is variable in our right hand side, look, after the substitution we got our right hand side in the term of t, here t and here is t, but previously it was in the form of x, log x, log x. So after the substitution we got a new equation in the form of t. So on the basis of this equation, we are going to use variable in our CF. So right hand side is in the form of t. So while calculating CF or writing CF, we are going to use variable t in the place of x. So it becomes e to the power alpha t bracket and this inside, and we will replace the value of alpha and beta which we have calculated from this. And finally we are going to get our CF e to the power 0 means 1. So this will going to be end up, and inside the bracket is our required CF, which is this. And after that we need to calculate PI. And we know PI equal to right hand side function divided by function of d. Then what we have got? Right hand side function. This is our right hand side function, t into sine t after the substitution, and this is our reference equation divided by function of d, and this was the function of d which is solving to a smaller part. Just we need to simplify the symbolic form of d equation, and whatever we got the simplified form, we're going to use this form. We should not send any of this term to here, or we should not cancel any other term by sending them there. So we got this our function of d. So our pi became right hand side function divided by function of d. So this is our equation. Now we see here our right hand side is the similar to the product of trigonometry and polynomial, and we have got the sequence, and the sequence was this. First we need exponential, then we need trigonometry, then we need polynomial, and we are solving from here to here, and here we have got the product of trigonometry and polynomial. This is like as polynomial and this is trigonometry. So first we know for the trigonometry we have to convert trigonometry in the form of exponential. After converting, we're going to solve with respect to exponential. Then after solving, we're going to solve with respect to polynomial with the help of binomial concept. We know this order as we have discussed earlier. So this, instead of sin t, we can write imaginary part of e to the power it. And now here it is exponential. So we should solve with respect to exponential, in where we have to replace d with d plus a. Here it is in combined form, it is in product form. So we are replacing d with d plus a for exponential. But whenever the exponential terms comes alone in right hand side, here it is in product, but if it comes alone, then we're going to replace d with only a, but it is combined form, so we are replacing d with d plus a, where a is I. So wherever we see the d, we will put there d plus I. Look, now we are going to solve with respect to exponential. So we will replace d with the d plus I. So here is d square, it becomes d plus I square plus 1. And we have done the work with respect to exponential. So this all term is just going to be appear like as product.
Open the bracket and we're going to get this from a square plus 2ab plus b square. So after getting this term, look here, this is I square, it cancelled with 1 because whenever we open the bracket of I square, then we're going to get minus 1 because I is equal to root under minus 1. If you square it, then we're going to get minus 1. So minus 1 plus 1 is cancelled, thus our I square plus 1 is cancelled here. Finally, we get our this d square plus 2id. Now we can see on the numerator there is only t, that is algebraic, that is polynomial. So whenever there is polynomial, we know there will be binomial concept. So with respect to polynomial, we should apply binomial. And we know in binomial concept, first we have to take the common of the lowest degree of the d. Look in this denominator, d to the power 1 has the lowest degree than d square. So we're going to take this total common from this both. So we took the common 2id bracket. And here will be 1 left plus d square divided by 2id. I'm solving. We're going to get up to here. So we have taken this common 1 by 2id. t divided by 1 plus d square by 2id, where if we cancel dd, we're going to get just d on the numerator, and downside there is positive power, and if we are going to shift it to the numerator, then the power going to be reverse, so it becomes minus 1 and it is multiplied with t. Now it is in numerator, and here we're going to use binomial formula. It is in the form of this form here, 1 plus x to the power minus 1, means here is plus, here is minus, then its answer will be alternating symbol like this, 1 minus x plus x square minus x cube, and continue. Look here, t has maximum power 1, so we're going to use x power up to 1. Then we're going to use this two term only, and this is our total x. So our format becomes like this, 1 minus d by 2i, which is total x whole to the power 1 up to this term only, because t has got only one power. And after applying binomial, we're going to send our t inside, then it will look like this imaginary part of e to the power it, and this is just being copied from top to down, just as multiplied. And this is our term 1 by 2id, and this is our formation after sending t inside of the bracket, which becomes t minus dt by 2i. Then after, we are looking at inside the bracket, d is multiplied to the numerator, and we know if d appears in the numerator, then we have to do derivative of the term with which it is multiplied, then it is multiplied with t. So we will do one time derivative as d has one power. If there is two power, then we will do two time derivative. If there is three power, we will do three time derivative. But luckily we have got one power, so we will do one time derivative. And doing one time derivative, we got 1 and d is disappeared. So on solving down further, we got up to this. And look here, again there is another d down the numerator, means d is appearing on the denominator. And we know if d appears in numerator, then we have to do derivative. If d appears in denominator, we have to do integration, that is antiderivative. So we did here antiderivative. Then the antiderivative of t is t square by 2, and antiderivative of this is t by 2i. Then finally we got this much after opening the bracket, t square by 4i minus t by 2i whole square. And this imaginary part of e to the power it will just be copied down as in product form. I have not copied, but you should copy it continuously. And there should not be any I form in the denominator. So we will move this I to the top on the numerator. This is how we're going to multiply this by minus I square. It is 2I square. Then I square is minus 1. And this becomes 4. 4 means it becomes minus 4. And here is minus. Then it is going to be plus. And here is going to be 4. And we're going to multiply here minus I square. So we got final expression like this, minus square t by 4i plus t square by 4. Then after, we had to copy this imaginary part of ei t as usual, and this is our solution form. Means we copy this here, and we are copying this from beginning up to now. And we know after doing all the solution, we need to again return the value of e to the power it. We copied imaginary part of cos t plus I sin t, which is the value of e to the power it, and we copy this in the form of multiplied. Finally, we're going to multiply this both. Here is 2 term, here is 2 term. After multiplying, we're going to get 4 term. 1, 2, 3, 4. After solving, we're going to write the only imaginary part. Imaginary part means the term containing I. Then we can see here, it has got I and this has got I. Look, this I square has been changed into 1. So it is not our concern. Just in another step, we're going to write our imaginary part, which is the term containing I form. Here is I and here is I. So we're going to copy this answer, and finally, look, we got here imaginary part of this one is copied here, and this one term is copied here, and the other terms are left because they are not imaginary part. So finally we got our pi. Means while removing imaginary part of this word, we have to remove I also from both. Then we got our this is our required pi. So we got our pi, means we can get our complete solution, which is given by cf plus pi. We return the value of cf, we return the value of pi. Then after, at the end, we have returned the value of t, which we had replaced with log x. Wherever there is t, we keep there log x. There is t, there is log x. There is t square, there will be log x square. Means wherever there is t, we will replace it by log x. Now finally our answer is in the form of x, as our question was in the form of x.